All right, we're going to get started. Thank you all for being here today. As home energy rebate programs roll out across the country, understanding their potential impacts at the state and community levels is more important than ever. My name is Caitlin Stenger, and I'm excited to guide you through today's session. My colleague, Jack Marinick, and I have worked closely with the Department of Energy and states to provide evidence-based analysis for the home energy rebates programs. During this webinar, we'll explore how publicly available ResStock analyses datasets can help states and communities evaluate the potential impacts of efficiency measures eligible for these programs. Of course, feel free to ask any questions anytime. Jack will be answering them live in the chat. We'll also have an open Q&A session at the end of the presentation, so stick around to join the discussion. Before we start, I want to provide some overview of NREL. NREL is a research institution, a world-class research institution with expertise in renewable energy, sustainable transportation and fuels, energy systems integrations, and building and industry. Today, we're going to be focusing on our buildings expertise. We often partner with industry, academia, and government, and we have 4 campuses that operate as living laboratories. Today's agenda, we'll be focusing on highly granular data-driven decision-making for national, regional, and local housing stocks using the data set called ResStock. Then we'll be looking at some examples of how to use this data in the context of home energy rebates. We'll be quantifying impacts, quantifying savings. Last, we'll have a section for questions and answers. The goal of this webinar is to introduce or refresh stakeholders on publicly available ResStock analysis results, specifically on use cases of the data that are relevant to understanding the potential impacts of Inflation Reduction Act programs in a state or community. Again, I'm going to reiterate, please add your questions to the questions and answers. We'll be taking questions at the end for dialogue. To start off with, we have ResStock, this highly granular data-driven decision-making tool for national, regional, and local housing stocks. You may be interested in understanding your local housing stock in the context of different kinds of upgrade packages or building improvements, and this particular tool can help do that. So what is ResStock and how does it work? First, we have a building stock characteristic database where we seek to understand prominent building characteristics and their prevalence in the building stock. Then there are over 100 probability distributions of various attributes. So this includes things like building type, size, location, vintage, HVAC system, insulation levels, and many more. We then have a physics-based computer modeling software, which we take this housing stock and we represent this set through 550,000 OpenStudio Energy models. This physics-based computing model helps to quantify the actual effects of energy consumption and many other factors. We take these modeling capabilities and we put this into our high-performance computing, our computer. We simulate these models. We process the results, these raw results, and then we apply scaling factors because this is a representative data set. And we'll get into what that looks like in the next slide as well. Last, we publish these data. Today, we are only focusing on the published data of this infrastructure. So this data is publicly available and open source to anybody who would want to use it. And we'll be going through examples of how to download this and what it could answer for you. And the question actually comes up quite frequently, well, how representative is ResStock? And on the left-hand side is a picture of a dog, a real life example where every pixel is a building. And then on the right side, we have what can be thought of as ResStock. Every pixel is a model. It's a lower resolution puppy picture is a great analogy for many use cases, but not for all. And so I just want to emphasize it can be useful at certain contexts and scales, but if you zoom in on certain parts of the lower resolution, you won't get a holistic picture of what's actually happening. And so we're we will be using ResStock. It's a representative of about 250. Each model is about representative of 250 different households in the US. And so it does provide a holistic representation of what's possible in the US housing stock. ResStock can tell you many different things. It can tell you housing stock characteristics, where the distribution of cooling is and things of that nature. It can show you socioeconomics, like area, median income, tenure, so who rents, who owns, and other questions like that. It can also tell you when and how buildings use energy through specifically 15-minute interval data, so you can get an analysis on peak demand as well. You can also examine the potential impacts of energy efficiency technologies like a heat pump water heater, or insulation. And then last, you can answer questions around improving indoor comfort and cooling and decreasing potentially harmful exposure to hot or extreme hot or extreme cold inside a dwelling. To start off with, you can download the ResStock data. Please visit the link. It should also appear in the chat. You will have to register an account. So before you do so, please register an account. It's easy and it's free. Then click on this Data Viewer tab in the bottom left-hand corner. This will take you to a screen that looks similar to this. We publish our most recent data sets at the top, so it's in reverse chronological order. We encourage users to use the most recent data set. We are always improving this data set, and the most recent one is going to have the most capabilities for it. From here, we can, the different kinds of upgrade building packages are listed here. So you can see the list here. We are only interested in metadata or annual results. So instead of that 15-minute interval, we're actually looking at an entire year. So we'll click on the metadata and annual results. And this will bring us to a data repository called OEDI. You can click by national or by state. And if you click by state, which will provide smaller data sets, you will be selecting Virginia as one of our many examples. And then you can choose between a CSV or a Parquet file. The difference here is that a Parquet file is more compressed and requires less space, but a CSV can be easily uploaded to softwares like Excel. Then when you open this up, you'll see this list of the baseline, the upgrade, and upgrade numbers. And you might be wondering, well, what are these upgrade numbers? If you refer back to the original data, the original web page, you'll see these numbers here, 1, 2, 3, 4. And these numbers correlate with 1, 2, 3, 4, right? So in this instance, we're going to be looking at number 6, Energy Star heat pump with electric backup plus light touch envelope improvements. And that is equivalent to Virginia upgrade number 6, metadata and annual results. We encourage all users, you're welcome to use technical documentation. This provides the specifics of what is actually available and what the specific measures are and the assumptions behind the modeling practices. When that data is downloaded, this is a view of the metadata and annual results. Each row is a building energy model. So thinking back to that photo of the pixelated photo of the dog, that's each pixel, right? That's a building energy model in this case. And then each row is a characteristic. It can be an input characteristic, what is characterizing the household and the dwelling, whether that's socioeconomics or the building type itself, or modeled output, which are those characteristics which include energy consumption, indoor air comfort, bills, and many others. There are differences between ResStock datasets. For example, we do recommend you use the most recent dataset release. There are time series results, and so those are 15-minute intervals. That data is much larger than the metadata or annual results that are provided, and which will be the center of this analysis, the focus of today's presentation. There are output metrics. We've increased the number of output metrics to include energy, carbon emissions, utility bills, and indoor air temperature. And for the most part, we recommend, again, using the latest version of the ResStock release, so that way you have the most capabilities at your fingertips. In this next section, we'll be talking about what to do with this data after you've downloaded it. You might have questions around how this impacts home energy rebates, and you might want to quantify these impacts. ResStock provides an evidence-based approach to answering some of the questions you might have. Questions could include, how could Idaho's households increase safe and comfortable home temperatures? It could also ask, what upgrade packages reduce utility bills in Missouri? Or what upgrade packages reach 20% energy savings in Pennsylvanian households with high utility bills? Or last, how could we reduce peak demand in Virginia? In this brown box, I will be providing the columns. There are often over 300 different column names. And so this is to provide a wayfinding device for you to reproduce this analysis on your own later. Our first question around peak demand in Virginia comes up because peak demand is a very important thing to manage for grid and distribution folks. And we know that that we should be addressing that and decreasing that, and buildings are an opportunity to actually decrease peak demand while also increasing energy efficiency. First, we can identify opportunities with ResStock. So in this case, we can quantify the number of households who use electric resistive heating, which increases peak demand. So 780,000 Virginian households heat with electric resistive heating. We can realize opportunities by looking at different upgrade packages. In this case, installing an Energy Star heat pump with light touch envelope improvements is the realized solution. And then you can quantify the effect of that particular solution. Of those households that heat with electric resistive heating, 663,000 Virginian households can reduce winter peak by as much as 6.1 kilowatts per household, so up to that amount. Our next section, we'll be looking at how to conduct this kind of analysis. And so we will move to our Excel demonstration. When you download the data, it will look like this. For upgrade 6, you can see that there are many columns here, and it can be hard to read it in this fashion. So an easy way to do this is copy the first row, create a new Excel document, and make your life easy and transpose these column names. This allows you to search through what might be relevant for your use case. And in this case, we are interested in specific analysis on peak demand. So you can just Control F, peak. You can see there's summer peak, winter peak. And then you can also look at the cooling load. But what's interesting is in our releases, we also calculate the savings on your behalf. And so you can use these saving values that are here. Our relevant column that we're going to be looking at is out.electricity winterpeak.kw.savings. I've pre-populated this analysis so that way we can make sure that things run smoothly, and also that you have the understanding that you might need. Here is the question, how many households heat with electric resistive heating? That was one of the first quantifying the opportunity here. And the answer is here, and it was also provided in the PowerPoint slide, but the approach is listed here in the Excel command. First, you would want to count all instances of electric resistive heating in the HVAC heating efficiency column. Then you would want to scale by the weight of the models. Again, remember that each model is representative of a certain scale. And so I will click on this so that way you can kind of see where we're going. We'll go to upgrade 6 CN, column CN. And you can find this by also referencing these columns here, but this is made easier so that way we can kind of show where this is at. So CN is right here in HVAC heating efficiency, and you can see the different characteristics that are available. We count the ones that are considered electric resistive heating. And then we scale by the weight factor. In our models, all of our weight factors are the same, 252 in this particular data set. Please use this weight to scale the results from models to a representative household count. Our next question is, well, how much would peak demand in winter decrease who previously used electric resistive heating? And there's an asterisk for that, for those who had an Energy Star heat pump installed with light touch envelopes. Again, that's the upgrade that we're looking at here. And what you'll want to do is we have that winter peak savings value. It's already calculated for you, so you can find that value which we identified previously. And winter peak savings would be a column all the way on the outside, on the out. And you would select that particular column and calculate specifically for households who have previously had electric resistive heating. And so that's the methodology that we use. We also calculate the 90th percentile to show a comfortable upper bound. The reason we use 90th percentile is just to show maximum potential for what could happen in by upgrades. Our next question is, how many households that had electric resistive heating and decreased their winter peak demand? And so for this particular question, what we'll want to do is we'll have to count all instances of electric resistive heating in the HVAC efficiency column where winter peak savings is greater than 0, right? So you're saving on peak demand, and then you'll scale that by weight of the models. This particular tutorial is just to show you how useful this data set can be, and also that you can use this in Excel, specifically for state level metadata analyses. And these can be extremely important to answer questions like changes in peak demand. Our next example focuses on heating and cooling systems in Idaho. We're curious, you might be curious to answer questions of how can we make sure that households are living in safe and comfortable home temperatures. First, we can identify opportunities. And so looking at building characteristics can be a great start. In this case, 33% of households in Idaho do not have cooling. This can be more urgent as heat waves become more prevalent. Our next analysis is we see 50% of households in Idaho heat with natural gas. And so we have this interesting mixture of no cooling and many households heating with natural gas. The home energy rebates, in this case, and we'll show this, can be used again to reduce utility bills, increase cooling access, and keep existing heating sources as a backup. And so what we mean by this is in this figure here, this is what it looks like to have a minimum efficiency heat pump, this illustration, but you also keep the existing heating system as a backup. So you'd keep, in this case, a natural gas furnace as a backup. And what this does is it adds resiliency to households, as well as it can decrease energy bills and provide cooling. And in the context of Idaho, 496,500 households do not have their cooling needs met. And what this means is they are experiencing, based off of the models we have, they're experiencing temperatures outside of what they have stated as their preference for set points. This also includes 164,500 households that do not have cooling. And so we can see that it's not just the households who don't have cooling, it's also other households who do have cooling who aren't having their cooling needs met. These households include households that have room air conditioners in maybe one room, but don't cool their entire dwelling. And so heat pumps in this case can provide a cooling benefit as well as energy savings. Our analysis shows that single-family households without cooling can save as much as $965 annually by switching to a heat pump with existing heating systems as backup. So what this means, again, you have your heat pump system and you have your natural gas furnace, and you have that as a backup system as well. In the top right-hand corner, we have the weights, the relevant columns for your reference moving forward. We'll also go into an example for Idaho's analysis on cooling and comfort. Again, I believe we are here, and I'll make this larger. One of the questions we asked is, how many households experience indoor air temperatures beyond their set point? And so we have a measure called unmet cooling hours. And so I'll show you where that is in this data set. What we'll do is we'll count all instances where unmet hours for cooling is greater than 0. That means they're having hours where they're outside of their comfortable range. And then we're going to scale by the weight. And so when we click on this, we'll show in the baseline condition. We'll go to column JB. There are many columns here, so I encourage you to make a little key for yourself in another Excel file like we did previously. And this column here is out, which is an output, unmet hours cooling, and this is annually. So this first building model experiences 177.5 hours beyond their set point. So those are uncomfortable times. You count those up and then you scale by the weight. We also asked the question, how many households do not have cooling? That was another question we asked. And what we will do is we'll count the number of households that have a cooling type of none, and we scale that by weight. So just to reiterate, we'll be looking at columns C, J, and heat pump. We're right here. In HVAC cooling type, you can see there's a central AC system and also that there's none. We are counting the instances of none in that instance, and that helps us calculate the values previously shown on the previous slide. Moving forward, you might be interested in questions around other states as well. Let's say instead of Idaho, let's look at Missouri, where it's a different climate and there are different conditions as well. In this case, that same segment for single family households without cooling can save as much as $790. So a little less than what we saw in Idaho for the same upgrade. And this is because in part, utilities vary by state, as well as because of utility rates, housing types, climate zones, and many other factors. And so it's important to think about how your specific questions can be answered with the right measures. In this case, for Missouri, maybe we want to increase this value of potential utility bill savings annually. And we look to more aggressive measures. And in this case, we look at a measure of a high efficiency heat pump with electric resistive heating for backup, as well as providing a heat pump water heater, wall and attic insulation, air sealing as well to reduce leakage by 30%. And in low and moderate income households, you can specify the specific income bracket, which can be relevant for home energy rebates as well. For low and moderate income households, which we characterize as 0% to 80% area median income, or AMI, can save as much as $1,700 annually by switching to a high efficiency heat pump. And this represents 1.17 million households. So what this means is 1.17 million households fall within the category of being able to upgrade to this high efficiency heat pump and heat pump water heater and insulation package in the low and moderate income household segment. This, of course, is going to be relevant for home energy rebate programs. What we have is, at this point, ResStock can be used to quantify households eligible for rebates and adapted to some state-specific rules. Of course, in this instance, the rules for the federal programs are briefly listed here, but what's important is we can characterize energy savings using ResStock, so we can identify measures that meet the mark. We can also look at eligibility requirements like area median income and filter to your community or to your state that you might be interested in. The last piece here is for the home electrification and appliance rebates. These rebates can only be applied to certain equipment. We have a wide range of measures that are available, and so you can select the measures, or as it can also be called building upgrades. So you can select the building upgrade packages and upgrade situations that meet the rebate requirements as well. And in addition to that, you can apply them to state-specific rules as well. This next question on home energy rebates in Pennsylvania, this is an example of trying to understand, well, who's going to be eligible and who has high utility bills. So what we show here is this is a filtered map for the number of households who have utility bill savings that exceed $3,000, and across the many different measures that we model. So have at least one building upgrade package that reaches that 20% or more energy savings mark. That 20% energy savings mark is relevant, again, to the home efficiency rebates program. And so what we see here is we see a map of distributed eligible households. We might want to, or you might want to, focus on specific counties. In this case, Montgomery and Buck County in this bottom right southeast Pennsylvania area is one area where you could select and understand which upgrade packages reach that 20% or more energy savings. And so when we select that data set, we can identify the different upgrades that are possible to reach that 20% threshold and calculate an upper bound, that 90th percentile utility bill savings. And what we see here is the enhanced enclosure, so providing insulation, as well as crawl space insulation, air sealing, and many other things, can result in $2,100 in utility bill savings. Of course, as we increase the investment, we also increase the reward in this case. So as we move from an enhanced enclosure to a high efficiency whole home electrification and basic enclosure upgrade, this means electric resistive heating, high efficiency heat pump, induction range, heat pump clothes dryer, heat pump water heater. We can see that households in this area can save as much as $3,800 annually. We provide these particular measures to provide a kind of case study, so that way, if you want to understand the upper bound of what's possible in your region, in your community, in your state, you're able to do so. Of course, if you don't have time to do these analyses, we do have dashboards that provide a great starting point. These are no-code dashboards, so you can click through them. If there's interest, we can also go through some of these dashboards in the question and answer. But these the first is a state-level residential building stock and energy efficiency and electrification dashboard. Shown on the left, this just provides a breadth of different upgrade packages, the state-level savings, as well as many other more detailed measures on building characteristics. The second is a utility bill impact dashboard. This impact dashboard helps to characterize things that are specific to the home energy rebates program, such as that energy savings threshold at those 20%, 20 to 25% that's specific to the home energy rebates program. And it can provide estimates on potential impacts, such as site energy changes, emission change, and utility bill changes as well. We provide the electricity rates and natural gas rates as well throughout that dashboard. With that, thank you all for attending, and thank you to the Department of Energy for supporting our work. It is my personal goal as a researcher to provide credible evidence for urgent problems like the one we have today. I hope this session was helpful, and please reach out if you have any additional questions. We'll be moving to questions and answers, and then we'll be stopping the recording at this section. Again, thank you for attending. Thank you so much.